Now see here, this is your question, this greatest integer modulus function. We have to check the point where it function is not differentiable. So here this is the greatest integer function, and your interval is from x greater than -1 and less than 3. This is given in your question. So this, since this is a greatest integer, so your integers will be -1, 0, 1, 2 and 3. Uh, Now for x here greater than equal to -1 less than 0, your this greatest integer, this will be equal to this will be sorry, I have to say in the opposite direction. For x is equal to -1, your value of x will be -1 less than 0. For this 0, your x will be greater than equal to 0 less than 1, and for is equal to 1, this will be x greater than equal to 1 less than 2, and for this 2 x is equal to 2, it will be x will be greater than equal to 2 less than 3, and for greatest integer this is equal to 3, this will be x greater than equal to 3 less than 4. So now I will go stage wise. So for x greater than equal to -1 less than 0, your value of y, this will be -1, and here this will be positive in this range. In this range this value will be positive, so I am going to consider the positive value. So 1 minus x, so this will be minus x. And again in the range 0 less than 1, your y will be equal to how much? 0. This will be 0, and in this range, say in this range, this will be positive, so I am considering the positive value, so this will be 1 minus x. Again, x greater than equal to 1 less than 2, your y, this is will be 1 and 2, so 1 between 1 and 2, this will be negative, so I am considering the negative part of it, and this will be equal to how much? X. Again for x greater than equal to 2 less than 3, your y will be how much? 2. This is greatest integer 2, and since again this part will be negative, so I am considering the negative part, so this will be your 1 plus x. And again for x greater than equal to 3 less than 4, your y will be 3, greatest integer will be 3, and this will be negative part, so 1 minus x, so this will be 2 plus 2 plus x. So here is your result, and here is your result, and you see that these are the testing point. Testing point is your 0, then 1, and then 2, and then your 3. These are your 4, these are your testing points. So here you see that these are your testing points. So here, so from here we get the conclusion that because these are the integers, so we get the conclusion here that these are your testing point, 0, 1 and 2 and 3. These are your testing point. So here we find that 0, there are two functions, and from left hand limit as well as and right hand limit, that is 0, here 0, here see less than 0 it will be this function, and greater than 0 it will be this function. So we can conclude that at 0 it is discontinuous, the function is discontinuous. I can check it for you. Say limit your x tends to 0 minus fx, that is equal to limit your h tends to 0 f 0 minus h, so this will be how much? Limit your h tends to 0 minus 0 minus h, so this will be how much? 0. And if you take right hand limit, so your right hand limit, see limit x tends to 0 minus fx, so this will be limit your h tends to 0, so this will be f 0 plus h, your this will be the function greater than 0, this will be the function, and this will come out to be limit h tends to 0 1 minus 0 plus h. So here your answer is C, this is 1. So here you see that at point 0 1, these are the turning points. These are the turning points, means these are the testing points, that is 0, 1, 2 and 3. And we see that in 0 they follow two graphs. Left hand side graph is this, right hand side graph is this. At 1 also this and this is for 1, for 2 this is this and this. Similarly for 3, there's 3 it is this and this. From this we conclude that it is discontinuous. The function is discontinuous, continuous continuous function is discontinuous at x is equal to 0, 1, 2 and 3. So at this, when the function is discontinuous at this point, so the function is also, it is not differentiable. So it is not differentiable, so it is not differentiable. So it is not differentiable at x is equal to 0, 1, 2 and 3. It is not differentiable at point 0, 1 and 3. So here again I am repeating the question. You see this is the greatest integer function and your limit is given here. So your integers are this -1, 0, 1, 2 and 3. So for -1 the range is this, for 0 it is this, and for 1 it is this, and for 2 it is this, for 3 it is this. And if we place this value in this function, we get this result. So from this result we conclude that it is discontinuous at point 0, 1, 2 and 3, as well as it is not differentiable at point 0, 1, 2 and 3. Now my next question, number of points in the interval minus into infinity to infinity, x square minus x sin x cos x is equal to 0. So what I am going to do is here, x square minus x sin x minus cos x is equal to 0. So here your x square is equal to x sin x plus cos x. So I am going to make two functions. One is say fx, that is your x square, and another is your gx. So this is equal to x sin x plus cos x. So now to solve it, I will try to find out the critical points so that I can get the value of x. I will try to find out the critical points so that I can get the value of x. To find out the critical points, I have to differentiate it. So when I differentiate it, here will be the product rule. So this will be sin x plus x cos x, and this will be minus sin x. So this comes out to be gx, that is equal to x cos x. So to find the critical point, your g dash x must be 0. So x cos x will be 0. So the point at which x will be 0 is equal to x is equal to 0, pi by 2, 3 pi by 2, then again 5 pi by 2. Similarly, if you go for negative portion also, it will be minus pi by 2, minus 3 pi by 2, and again minus 5 pi by 2. Now, if you draw a graph, that is for this function, if you draw a graph, we have to draw this graph for this function. I'm going to draw this graph for this function. So here the graph will be somewhat like this. See here, this is 0, then pi by 2, then 3 pi by 2, 3 pi by 2, after that then 5 pi by 2. That means similarly here this will be minus pi by 2, minus 3 pi by 2, and then here minus 5 pi by 2. So let me see, when you take 0, x 0, so this is 0, this will be 1 is somewhere, let's say like this here 1. And when you take pi by 2, so when you take pi by 2, this is pi by 2, this will be 0, and this pi by 2 1, so this will be pi by 2. So pi by 2, its value is suppose 3.14 divided by 2. So 3.14, 1 point something, it must be greater than some 1, so it must be greater than somewhere like here, say let this be pi by 2. So at pi by 2, your value is here. First point is this 0, and then at pi by 2 it is somewhere here like this. Now again, in 3 pi by 2, here you find that in 3 pi by 2, what happens? 3 pi by 2, that means here this is 3 pi by 2, 0, 3 minus 1, and this will be minus 3 pi by, this will be minus 1, and 3 pi by 2, that will be come out to be 3 by 270 degree, 270 degree is minus 1, so it will come out to be minus 3 pi by 2. So minus 3 pi by 2, that means it is going down somewhere like this. Instead of let me take one more thing, say let me take this is 3 pi by 2 means 270, so in between this here will be pi, here will be pi. So if you take pi here, then if you take pi here, then this will be minus 1, minus 1, that means minus 1 somewhere like this, minus 1, minus 1 somewhere like this. So again this minus 3 pi by 2 will be somewhere like this, 3 minus 3, at 3 pi by 2 it will be minus 3 pi by 2 somewhere like this. Then again 2 pi, when I come to 2 pi, here it is 2 pi, so when I come to 2 pi, here it is somewhere like this, here minus 3 pi by 2, 3 pi by 2. So again pi, 2 pi, so 2 pi, this will be 0 and this will be 1, so this will be 1, 2 pi, this will be somewhere like this, somewhere like this. So your graph will be somewhere like some of this type, this type. Your graph will be like this type. And similarly for minus pi by 2, it will be minus pi by 2, minus positive, so positive it will be somewhere here, this somewhere here. Again here minus pi, for minus pi you will be, it will be minus pi, this will be positive 1. For minus pi it will be uh, minus pi. So for minus pi, this will be 0, and this minus pi, that means positive, it will be again minus pi, that will be positive, that means is equal to minus 1. Minus 1, that means minus 1. So minus 1 somewhere, it will be somewhere like this. And again for minus 3 pi by 2, minus 3 pi by, this will be 0, this will be minus 1, minus plus 3 pi by 2. So plus 3 pi by 2, here this will be again your minus, so this will, it will be minus 1, and again here this is your 2 pi, minus 2 pi, here this is minus 2 pi. So here you see that what happens if you take minus for pi, minus pi by 2, it is here somewhere pi by 2 like this here, because, and for minus 3 minus pi it will be minus 1, so here again minus 3 pi by 2, this minus 3 pi by 2, it will be plus 3, it comes out to be minus, so minus, that means here this is cos, this is negative, because if you take minus 2 pi here again, this will be 0, minus 2 pi, that means it is positive 2 pi 1, so positive 2 pi 1, it will be somewhere like this, positive 2 pi 1, it will be somewhere like this, value is 1. Now the problem is here that your graph for minus 3 pi by 2, there is a problem for minus 3 pi by 2, because this is 0, and for minus, that is minus 1, that is, see again, see, x sine x, so 3 pi by 2, and sine 3 minus sine minus 3 pi by 2. So this will be how much? This will be again minus, this is minus, because sine minus theta is equal to minus sine theta. So this will be positive 3 pi by 2 into sine 3 pi by 2, but this 3 pi by 2 is minus 1, so result is again minus 2. So it will be somewhere like this, here somewhere like this, 3 pi by 2, it will be somewhere like this. So again, it is clear now. Your graph will be somewhat like this, going on, then here, then here, again here, and after that it will go like this, something like this. And next, here this is a parabola. So your parabola, your graph will be somewhat like this. Your parabola, so your graph will be somewhat like this. So there are two intersection point. So number of points for which this is equal to 0. So these are the two intersection points. So so their number of zeros, this function will be 0 at these 2 points. So there are 2 points where this function will be 0. Now my next question is, fx is equal to x square minus 1 by x square plus 1 for every real number x, then minimum value of f. This is a very easy question. You see your fx, this is x square minus 1 by x square plus 1. So this can be written as 1 minus 2 by x square plus 1. This can be written as this. So here you see that the minimum value of your 2 by x square plus 1. So minimum value of 2 by x square plus 1 is 2, because naturally x square, so it is anytime positive, its minimum value is 0. So 2 by 1, it is 2, it is clear. So since 2 is the minimum value, so the minimum value of fx, that will be 1 minus 2, that is equal to minus 1. So the minimum value of the function fx will be how much? Minus 1. This is an easy question. Not so tough question. Only the method is that here you have to split it, so that here you see, when I split it, everything is clear. This minimum value is 2, so the function fx its minimum value is minus 1. So this is your answer. Now my next uh, question is, your f r to r this, and fx, this is the function, and this, and hx is the function in which both these functions are included. Maximum of fx and gx if x is less than 0, minimum of this and this if x is greater than 0. We have to find the number of points at which hx is not differentiable. Means maximum of fx and gx if x less than equal to 0. Here you see less than equal to 0. Here your function fx is equal to modulus x plus 1. So, and your gx function is x square plus 1. Here you see x less than equal to 0. So x less than equal to 0, here x, let you take x is equal to 0. So here at x is equal to 0, your fx is equal to 1, and your gx, that is also equal to 1. And for x is equal to 1, here you find that fx is equal to 1 plus 1, that is 2, and 1, here 1 plus 1, that is 2, and your gx, that is also 1 plus 1, that is your 2. Here you see that uh, x is 1, this is the 2. So from here we find that these are the point of intersection. These are the point of intersection of the two graphs. This x is equal to 1, and at x is equal to 1, and at x is equal to 0. We find that from this we find that at x is equal to 0 and at x is equal to 1, these are the point of intersection of the two graphs. So number of points at which it is not differentiable, we have to find out the number of points. So here if we draw the graph of these two functions, here for this is a parabola. So here this is 1, somewhere this is 1. So your graph will be somewhat like this. This will be the graph of gx is equal to x square plus 1. x square plus 1. The graph of this function will be somewhat like this. And for this modulus, your graph will be somewhat like this. So this is the point of intersection. So here this is the point of intersection. So here for minus 1 also it is same with 2, and for x is equal to minus 1 also it will be the same, and for 1 also it will be the same. So this point is 1 comma 0, this is 0, and this is minus 1 comma 0. So the most important point is that when there is a sharp turning at any point, when there is a sharp turn, so graph is going like that, at this point we have to find the where it is not differentiable. So here at this point, so the graph, it gets a sharp turning. At this point there is a sharp turning, so at this point, it is not differentiable. So it is not differentiable at 0. It is not differentiable. So at this point it is not differentiable. Not differentiable. It is not differentiable at say x is equal to minus 1 comma 1 at this point, because the curve gets a sharp, you must remember, when the curve gets a sharp turning, at that point it is not differentiable. So it is clear that there are 3 points, the number of points, that means there are 3 points where it is not differentiable. There are 3 points where it is not differentiable. So from this, this is the answer. So the most important point here is that when the graph takes a sharp turning, at that point it is not differentiable, because your left hand derivative is not equal to your right hand derivative.